Let's continue with our work on general equilibrium, specifically using the Edgeworth box diagram. Now, we ended our previous video on this specific equation, and I'll continue with it now. But just before that, you'll see I've loaded them. They uploaded both of them, the first two. So if you enjoy it, if you like it, if you add values, please like and subscribe, share the videos, forward it to all your friends, and please play them in the background, let them run. Doesn't cost you a cent. It helps the channel a great deal. So thank you for your support. So in terms of recap, let's quickly recap where we are at the moment. For those that haven't looked at let me see if I can delete these things. Oopsie. Just delete this old slide, sorry. And we're gonna insert a new slide. Let's take away this mumbo jumbo. And that one there. Copy, paste. Let's paste a couple. Paste. Let's paste that number. And remember, as you might know from previous videos, I have to save the whole time. So, and a very, very important equation or system of equations when we work with general equilibrium is the marginal rate of substitution equations or related equations. Okay, so just as a refresh, our marginal rate of substitution x for y is equal to the slope of the indifference curve, which is the difference of y over difference of x. Okay. Change of y over change in x, so that's the slope of the indifference curve. But it's also equal to the marginal utility of x over or divided by the marginal utility of y. Now that's for person A. Okay, that's for person A. And the same would be true for person B, because remember we're working with two households, two persons, two households, two countries, whatever you want to call it. So in that case, the marginal rate of substitution x for y is also equal to the slope of the indifference curve, or the marginal utility of x over the marginal utility of y for person B. And given that both of them, well, let me put it this way, we basically say that at general equilibrium, the marginal rate of substitution x for y for person A must be the same as the marginal rate of substitution x, y for person B. This is the point of general equilibrium. This is a steady state situation. At that, demand and supply for Coke is in equilibrium, and demand and supply for haircuts is in equilibrium. So at that point, we have two partial equilibriums. We have a market equilibrium in the Coke market. We have equilibrium in the haircut market, meaning we have an equilibrium price for Coke and we have an equilibrium price for haircuts. So that means that is the price and quantities of these two items that were determined by the trade, meaning the market. The market determined that using basic demand and supply principles, etc., etc. Okay. So I hope that makes sense so far. Okay. So let's go back to our Edgeworth box diagram now. Let me see if I can. Let's see if I can copy this one, because that's the one that we're working with. Okay. So just to refresh, let's just to refresh that we have person A and person B. In this case, we've got households. or persons, doesn't matter. It could be either one of the two. And each one of them have a combination of Coke and haircuts, which is the initial endowment. So in this case, A had 6 Cokes and 2 haircuts. B has 4 haircuts and 8 Cokes. So in this case, my total endowment or total amount of Cokes in the economy is 14 and total amount of haircuts in the economy is 16. It says of this 14, A has 6 and B has 8, and of the 16 haircuts, A has 2 and B's got 14. Okay, so I hope that makes sense. Okay, so if we plot that, we take that out, right? If we plot this, our initial Edgeworth box diagram looks as follows. Let me just take this out, make it clean, and there we go. Okay, so I hope that makes sense. That must be 14, not 4, must be 14. I'm looking at it and say that's wrong, because the 14 plus 2 must give you 16, and the 6 plus 8 must give you 14. So that's our initial equal. So the question is, this initial point here, as indicated in green, this initial point here, let's call it point O. Don't use O. Let's call it point, what shall we call it? Point F. Point F. That initial endowment at point F, is that an equilibrium position or not? Because remember, if it's equilibrium position, they're not going to trade. They're going to be happy. Even if one of them wants to trade, but remember the key, I keep on repeating this, they both must trade, meaning they both must be better off with trade. It's not going to be a situation where one trade and one is worse off. That's not going to work. General equilibrium is the state, call it an efficient state, where nobody can trade without one being worse off. It's the same as, let's look at your production possibility frontier, efficiency. To produce more of X, you have to decrease more of Y. That's efficiency. So, is this point equilibrium? Meaning, is this an efficient point for both of them in terms of the allocation of the resources, the prices? So you can see there's a whole lot of things that we can derive from this specific point. Okay, so the question is, so remember, we're working with indifference curves. So if, remember our steady state, marginal rate of substitutions must be equal to one another. That means the indifference curves must be a tangent. So how would that look? So let's say the one indifference curve looks like that, and then the other indifference curve must look like, oopsie, sorry, I don't want to read all thumbs, it's not, okay, perfect. It doesn't shut down. But it's difficult with these pens. It must be something like that. So at that point there, okay, let's make it a nice green point there. At that point there, you see that the two indifference curves are a tangent, meaning they share a slope. So both of them share exactly the same slope, okay, because it's a tangent. And therefore, at that point, this satisfies this requirement. So when the two indifference curves, the indifference curve of person A and the difference curve of person B is a tangent, then we know that their marginal rates of substitutions are exactly the same. And therefore, they're maximizing their utility given the set of resources they have or after they traded. So any further trade will either, if there's additional trade, then it implies that somebody must be worse off, okay? Because you always want to be at your highest indifference curve. So let's quickly put that into perspective. So let's again say, okay, that there's one indifference curve. and there's a second indifference curve. Okay, so this will be person A's indifference curve, and that will be person B, because person B is there and person A is here. So in this point there, that is equilibrium, general equilibrium. Okay, so that's efficiency, blah, 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 blah. The whole tutti frutti. That happens at that point when the two indifference curves are tangent, because at a tangent, they share exactly the same slope. And remember, we said that the slope of the indifference curves are also equal to the marginal utility over x and the marginal utility over y. So they derive the same amount additional utility from increase in consumption of x and increase in consumption of y. And therefore, this is the steady state or general equilibrium. You see, it's also efficient. So for example, now, if A wants to increase its utility, it must move this way. So meaning there. But the only way you can do that is if B moves that way as well, which means that they'll move that way. Now in this case, person A benefits because he's moving from this indifference curve to that indifference curve, which is a higher indifference curve, because remember A goes this way. But for that to happen, to go to this specific point, call it the pink point, B must move from this indifference curve to that indifference curve. Okay? And as said, B wants to move this way. So in fact, if B moves from this indifference curve to this one, it decreases his utility because this is at a higher point away from the origin, meaning this derives more utility than that one. This one derives more utility than that one. So if we're at either point, and that's why it's called also efficiency. If we're at either point, let's say that was the original point, and we move this way, then you'll see that B will benefit and A will have to sacrifice. Now, why would A and B want to sacrifice their utility? They're not going to sacrifice utility. So they're going to bump heads and say, well, they will only trade if both of them can get better. And that makes sense. If you're at the point where you are maximizing your utility, but for the other person to increase his utility, you must decrease your utility. You're going to say, no, that's not going to work. We're not going to work. I don't want to be in a worse position than I'm currently not. And therefore, they will stop trading because they both cannot improve their efficiency, their utility, without the other one sacrificing his or her utility. So that makes sense. So this point here is what we call, as I said, general equilibrium. It is steady state, it is efficient allocation of resources, prices are in equilibrium, etc. So there's a whole lot of things that happens at these 2 points. But the point is, I cannot move from a general equilibrium point to another general equilibrium point. I can only do this if both of them are better off. Now that becomes quite tricky. So let's, for example, look at this situation. Okay, let's look at this situation. So here is person's A indifference curve, and there's person's B indifference curve. So let's say person A sits at that point on the indifference curve, and let's say person B sits on that point in the indifference curve. Doesn't matter, because it's exactly the same utility. Then they can trade, because person A can move this way, and person B can move that way. So they're both increasing their total utility. And therefore they will trade. So they trail the next round. And they'll trade to this point. Okay? And they will still trade because they can both get better. So they will trade like that, and they will trade like this. So they could actually have overlapping indifference curves. But they will still trade because they can even get better in there and in there. Oops, sorry. Let me see if hopefully it doesn't. Okay. And there we go. And another one. And I can trade there. So you'll see the gap between the two becomes smaller and smaller. And you see there's still a gap here. Now, let's do another pen. You'll see there's still a gap there between the two indifference curves. Okay, and that's a surplus area. That's where they can still, that area there allows them to continue to trade. It's only when that area between them is eliminating, meaning that area between the two is zero. There's zero space there. There's zero gap there. It's only that because they can still trade. So the marginal rate of substitution equal to the mark means there's no space between them, i.e. they are a tangent. But whilst there are space between the two, okay, they will continue to trade because they can both get better. They're not at a point of the efficient allocation of those commodities or resources. Okay, so I hope that makes sense. So that's the indifference curve. You always want to be, remember again, an individual household wants to maximize his or her utility, which means that person A and person B wants to be at the highest possible indifference curve. Okay, so they will trade and trade and trade while they can both increase their indifference curves, while they can increase their total utility. But at a point where both of them have maxed out, not maxed out their utility, they've comparatively maxed out their utility, meaning I can still increase my utility. But for me to increase my utility, you must decrease your utility. Now, as I said, unless he or her is a saint, feel sorry for the other person, that could indeed happen. So it's not impossible, but it's highly unlikely because we assume that these two individuals, A and B, or households, are utility maximizing individuals or households. That's their goal. Okay. So let's look at this again. Let's look at this point again. Okay. So it could be a situation. So we have this situation. So let's say person A is here. There we go. And person B is there. Okay. So that's person B. And that's person A. So at that point, what happens? A whole lot of things. At that point, the marginal rate of substitution for both individuals are exactly the same because it's a tangent, and therefore they will not trade. Coming back to what I said now, they will not trade because there's no gap, there's no space between the two indifference curves. The indifference curves, that remember that space is zero. What means if that space is zero, it means that the marginal rate of substitution is not the same. So when the space is not zero, it means the two marginal rates of substitutions are not the same. In this case, the space is zero. Therefore, the two marginal rates of substitutions are exactly the same, and they won't trade. They will be happy. They're maximizing their satisfaction. The point is efficient, steady state, prices are in equilibrium in the two individual markets, etc., etc. So that's fine. Then that's good. But let's say we have a situation like the following. Okay, so let's quickly just see if I can delete that. Delete that. Now, what's that point there? I don't know why I made that point there. What's that point there? I don't know. Also don't know why that point is there. Anyway. Oh, that's the numbers A and B. Okay, so don't confuse myself. Okay, so let's quickly have a look and see that, let's say this is A again. This is person A. And person B is like that. So I must, sorry, we could just go back. Just go back and let's redraw it like as is. Sorry, it's always difficult to draw it with these bloody pens. So we have an indifference curve of A there. and we have a indifference curve of B there. So that's person B, and that is person A. I can clearly see this is not efficient. This is not the efficient point, okay? Because this is this gap. Remember this gap that we keep on talking about. This gap here between the indifference curves. While there's this gap between the indifference curves, the marginal rates of substitutions are not the same, okay? The marginal rates of substitutions are not the same, and therefore they will trade. Now, they will trade, meaning person A will move this way, and person B will move that way. And this movement suggests that they're increasing their total utility, because when A moves this way, it goes to a higher indifference curve there, for example. And B increases his utility, also go into a higher indifference curve. But you can see there's still the space there. Now the space is that, for example, and so forth and so forth. I think you start getting the picture. And so they will trade. And what does trade mean? Trade means buying and selling. And every time you buy and sell, it has an influence on the price and quantity are in that specific market, meaning the price and quantity of Coke and haircuts. And that's the whole point of the general equilibrium of the Edgeworth box diagram, is to allow us to plot these situations or to demonstrate this specific scenario where we have an initial allocation, and whether this initial allocation, okay, whether this initial allocation is whether it will allow us to trade or not, okay. And so this is the use of the Edgeworth box diagram. So let's quickly just go for it again. Let's quickly copy and paste it in there again in its raw format and see if I can delete this one and delete that one and delete this and delete that. So we are at point F. So the question that arises, is that point F in general equilibrium? Okay. So for that, we have to calculate the marginal rate of substitution for person A and the marginal rate of substitution for person B. Okay. So that could be, let's say, I think A we've done. So that could be, so let me just quickly go. So that could be, it's difficult to draw these things nice and accurately. Something like that. And B could be something like that. Okay. So let's just quickly redraw it. Make it nice, and could be like that. That's person A. And let's say person B. Okay, so there we are. So we're at point F. So you can see, well, let's do it this way. Let's do it this way quickly. So that point is similar, similar to that point there. So in this case, point F is the same as that point there. Now, it should by now be obvious that this point there is not general equilibrium. This is not efficient, because we have, oops, sorry, oops, don't, please don't, no, no. Let's see how much I've lost. That's the part. That's, I keep on. Okay, so that's point F. That's now equilibrium position, because they are, the marginal rates of substitutions are the same, etc., etc. But let's, for example, take this out. You see, that's the thing. If I press buttons here, the damn thing just shuts down for whatever reason. Where's my pens now? Okay, so person A, I think as we said, person A is blue. So let's do it this way. There's person A's indifference curve. Now, you'll see, notice how indifference curve always looks different, but it's difficult to draw that nicely with this pens. And this one would be something to that effect for B. So what you can see is there's a clear space between the two indifference curves. And while that space is there, remember we put it in this context, you see that's what you see there as well. As long as there's space between the two indifference curves, given that they both run for this point. So in this case, there's no space. And so therefore this initial allocation is also the general allocation, general equilibrium allocation. There won't be any trade, this is efficient, etc. So there, honky dory, by hook and by crook, the allocation, they derive maximum utility from their individual allocations, they cannot trade, blah, 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 blah. So in that point, both of them are as happy as can be. They both are very, very, very happy. No problem with that, okay? And so there won't be any further trade, there won't be nothing, okay? But that's not always going to be the case. And indeed, let's assume a situation like this. So you have the same initial allocation, but your indifference curves don't form a tangent at F. They cross at F, so meaning it indicates their initial allocation, but you still have the space between the two indifference curves. And as soon as you notice the space between this indifference curve, then you know this is trade. So this is your tradable area. There's a potential for them to trade, for them both to increase their marginal of their total utility. And they will trade until the space, as we said, becomes zero, until this tradable area has been eliminated. And therefore they will trade. And the question is who will sell and who will buy? The question is who will sell and who will buy? And so one can intuitively say that they will move from this point somewhere to that point. Somewhere between where the distance between these two indifference curves are the largest. That's where they will move towards. So they will move from, let's call it the initial equilibrium F, they will move to the next equilibrium point, G. So they will go from F to G. Okay, so they'll move from F to G. So you'll see that where, so let's quickly, I need to keep on saving, boys and girls, please remind me. So let's put it that way. So there's the one difference curve and there's the others. You can see the difference there between the two. Let me put it in, oops, before I press that button again. And then it shuts down. I'm going to be very happy. The difference there between the two indifference curves are much less than the difference there, which is much higher than the difference there. So intuitively, the new point, the point will be somewhere there. That makes sense. Won't be there because you still going to have extra space. Because let's say they go like that, they're still going to have space. And therefore, it makes sense that they're going to move from point F to point G. They're going to go from that point to this point. Because the difference between the difference curves are the highest there. The point is, they're going to move from point F to point, oops, I want to press it, that button the whole time, to point G. So what happens for A and for B when they go from F to G in terms of Cokes and haircuts. What happens? And the Edgeworth Box diagram, to a large degree, will guide you into this. It will tell you what's going on. Okay? It will tell you what's going on. So, at point, now let's see if I can, at point F, A has 6 cokes and it has 2 haircuts. What happens at point G? At point G, person A has more haircuts but less coke. You can see that. To go from F to G, person C will sacrifice coke, meaning he will supply coke, and he will demand haircuts. So at that point, person A will decrease coke, he will supply, and he will increase haircuts, he will demand. What happens to person B? What's happened to person B? Person B, on the other hand, go from this point of 14 haircuts, he decreases to whatever that amount is, and he goes from 8 cokes, he increases with the same amount as what, because they still have to be the same. So for B, exactly the opposite happens. It demands coke and it sells haircuts. And there's your trade. A will supply cokes, B will demand cokes. To go from F to G, A will demand haircuts and B will supply haircuts. And that will have an impact on the price of cokes, and it will have an impact on the price of haircuts. Will the prices increase or decrease? That becomes a topic for a later presentation or discussion when we're going to go to relative prices. And we'll get to relative prices because it is important, because it partial equilibrium assumes a new equilibrium price and quantity, which we haven't yet done. So we'll get to that. So we'll get to the effect of prices. But for now, what I just want to get through to, or for you to understand, is this movement from F to G. F is the initial endowment, and G is the general equilibrium position after trade. So from F to G, there will be trade. Why? Because at this point, both can become better off, and because both can become better off, they're not efficient, they can trade, they will trade to somewhere there. You see, they won't trade this way because there's no possible tangent here. So they can't trade this side. They're only going to trade this side, and they won't trade. So let's quickly, they won't trade here, because you see, a tangent is not possible, and they won't trade there because a tangent is not possible. They will only trade within that point there and that point there. Okay, and they will new steady state will be somewhere where the difference between the two is the furthest or is the most. And that implies that we're going to go from F to G. And that suggests that go from F to G, the coke endowment, A will sell coke because his amount of cokes will decrease, and he will demand haircuts because his demand for haircuts will increase. On the other hand, if A demand haircuts, then B will supply haircuts because he's going to decrease his amount of haircuts. And he will, if A sell cokes, B will demand cokes. He's going to go from that position to this, from there to here. And therefore, as I said, they will trade the whole time like this. So A will continuously to sell coke and buy haircuts, and B will continuously sell haircuts and buy coke until they're both at a state where they don't want to, where A doesn't want to sell any cokes further and B doesn't want to sell haircuts any further. And that is a position where we find ourselves, like here, when we're now in a new general equilibrium position. So we went from a situation, an initial endowment of F, to a general equilibrium position of G. okay, through trade, meaning buying and selling of cokes and haircuts. Okay, and so at point G, we have a situation where our marginal revenue is equal to marginal rate of substitution for A, marginal rate of substitution X and Y for A is equal to the marginal rate of substitution X and Y of B, this position A. And therefore, this is now what we call general equilibrium, and this is the efficient allocation of resources. If this is the efficient, we can also say this is the inefficient allocation, this is suboptimal allocation, etc., etc. So there's a whole lot of things that happens at point G. Okay. So I hope that makes sense. And I'm going to park it for now there, because I want to, the next video, look at the impact of, or put it in mathematics, what we said here, because here we just derive it visually. Okay? We're looking at this from a visual point of view. We can actually do the calculations, etc., etc. And we're going to move into a situation where we're going to look at what's the impact on the relative prices, etc., etc. Okay, so let's park it for now. I hope this is still making sense, and I'm being, it's working. It's working. So feel free to leave me a comment. If there's anything that you want me to repeat or not sure, I'll happily respond to you. Okay, so I thought of something now, but let's park that for our next video. So with that said, I'll see you on the other side.